A very good morning. Myself, Dr. Ramesh B T, Assistant Professor in Mechanical Engineering Department, JIT, Davangere. Okay. I'm going to handle this subject. The subject name is Engineering Graphics with a subject code 18 EGDL 15 15 bar 25. If it is in the first semester, it is 15. If it is in the second semester, it is become 25. Okay. The subject name is Engineering Graphics. Okay. Uh, So this is what the subject name, engineering graphics, and it is comes in the either semester first or second, according to the VTU syllabus. And the teaching hours, 2 hours theory and 2 hours for the practical purpose. And marks, it is a same as your theory subject. Actually, this subject is considered as a theory subject. It is both either theory or practical. Okay. So the marks is like a theory, but we are conducting this exam like a lab. So internal marks is 40 marks and external 60, but you are going to write for 100 marks and automatically it will reduce to 60. And the total examination hours is 3 hours. Regular theory paper, like your regular theory paper. And for the VTU credits, it is of same 3 credits. And first thing, why we have to study this subject? That is what the course learning objectives. A course learning objectives. Why we have to study this subject means why the university put this subject for the first year common to all the students. So what purpose? In that, the first objective is to expose students to standards and conventions followed in preparation of engineering drawings, means for all subject, not only for mechanical, civil, electrical, electronics. So all branches need a engineering drawing. Means you exposed to some drawings. May civil engineers may expose to drawing like a bridge construction, dam construction, okay, or any other house or building construction. They need a drawing. And for electrical students, they need a drawing for transformer drawing or electrical circuits, okay, or else some generators. So all these represented by drawing. For electronic students, yes, the microprocessor, microcontroller, or the circuit, whatever the motherboard circuits, whatever there, it is represented in drawings. Similarly, for mechanical also, for all the machine devices or machines are represented in drawings. And for electronics or computers, computer science students also, they need a drawing for representation of their uh, okay, the drawing, they needed drawing for representation of the laptops or systems or an output devices or input devices. All those represented in a drawing. So for all branches, students need to learn this engineering drawings and they have to follow. Not only just drawing the component, they have to know what is the standards of drawing and what is the conventions followed in the engineering drawing, that I'm going to explain in the further classes. And to second objective is to make them understand the concept of orthographic and isometric projection. So they are the types of projections. You have to understand what is meant by orthographic projection and what is meant by isometric projection. They are different, they are not same. So orthographic means exactly we are observing object like a perpendicular, exactly perpendicular to our eye we are going to observe the object, and the same thing we are going to draw it on the either drawing board or any other output devices. So that is what the orthographic projection. Okay, ortho means exactly perpendicular. That is 90 degree. Ortho means. Isometric projection means the same object. It is in orthographic we are going to see the top view at a time only. We can able to see the top view, or a front view, or a side view. But in the isometric we can able to see top view, side view, as well as front view in a one single view. So that is called isometric view. So that we are going to discuss in the further classes. What is meant by orthographic and what is meant by projection. So you have to know what is what are the orthographic projections and what are the isometric projections. That is a mandatory to understand the engineering drawings. So that is the second objective. And the third objective is ability to develop or conveying engineering information through the drawings. So, so engineering drawing or a drawing is an a universal language. So we have to communicate our whatever our drawing or what our idea through the drawing only. Okay, so drawing is the best language to communicate all over the world. So whatever our ideas are there, we have to represent in drawing and we can communicate easily. So that is the third objective. And the fourth objective, to make them understand a relevance engineering drawing in a different engineering domains. Yes, of course, that is what the same thing. We have to understand the importance of engineering drawing, and we have to capably, with successfully, we have to implement those drawings in all engineering domains. And objective six, to develop ability to produce engineering drawing using a drawing instruments. Of course, there are two types of drawing. One is manual drawing, and other one is a system-oriented drawing. That is what CAD, computer-aided engineering drawing. And as a manual drawing, we need instruments, different types of instruments, like pencils we need, like scale we need, like drawing boards, drawing sheets, project, and mini drafters, different types of protractors, compass, okay, set squares. They're all instruments. By using those instruments, we can very effectively we can able to draw engineering drawings. Okay, that is manual drawings. And of course, we need tools like a CAD, some of the softwares like a solid edge, AutoCAD, okay, solid ST5, solid edge ST5. There are so many tools are there. They are used to draw the same drawing in a system. Okay, so manual drawing and system oriented drawing. And the last objective is to enable them to use computer aided drawing packages for generation of drawings. That is what the same thing I told. There are so many packages are available: Unigraphics, Catia. So many different packages are available. Drafting, okay, modeling and drafting packages. So if you study this engineering graphics, so it is very easy to, or it is very easily understand the packages like Unigraphics, Pro-E, so many different modeling and drafting softwares. So these are the main course learning objectives. So based on this, frame the syllabus, your syllabus for engineering graphics. So this is what the module 1. Of course, there are 5 modules: module 1, module 2, module 3, module 4, module 5. So 5 modules. So the first module, as usual, it is a purely an introduction to the computer-aided sketching. So what is meant by drawing, what is meant by engineering drawings, what is the standards, and what is the types of lines, what is dimensioning, what is materials, what type of materials do we represent. So different materials in a different representation. And what is meant by HP, VP, RPP, horizontal plane, vertical plane, 2D, 3D. So there are so many different types. Okay, and commands. What are the commands we are using? Line commands, points commands. Okay, polylines, square, rectangle. So these are all basic knowledge to understand the computer aided sketching. So that is comes in the first module. Okay, so first module is purely in theory, just an introduction to the drawings, what are the tools we needed, and what is the types of projections, what is the views, and what are the commands we are using. Okay, and second module. So first module, it is not for your examination, it is just only for the understanding purpose. Okay, it's only for the understanding purpose. If you know thoroughly the first module, and then you can easily understand the projection of planes, lines, points, solids, and isometric. So for thorough understanding, you should go through the first module. Okay, without first module, you cannot understand the further modules. That's why the first module is important, and it is not for the examination purpose. Okay, and the second module is purely an orthographic projection of points, straight lines, and planes. Okay, here you have the options. Points is not for the examination purpose, only just to understanding purpose. And straight line and planes, you have the options. Either you can go with the straight line projection of straight lines or projection of planes. There is an option. Any one you can attend in the examination. Okay, either you can attend the line problem or you can attend the planes problem. So in our college, regularly we go with the more concentrating on projection of planes rather than the projection of lines, because planes, if you thoroughly understand the planes, it is easy to understand the projection of solids. Next chapter there is a interlink between the projection of planes and the projection of solids. Okay, and in the projection of straight lines, again there is a first quadrant, and we are only discussing on the first quadrant. Okay, so true length, apparent length, and apparent inclination, true length, inclination, reference plane, and problems based on only those things. There is no problems based on the midpoints. We are not discussing problems on the midpoints. So come to the projection of plane surfaces. That is all projection of planes. So here there are different planes: triangle, square, rectangle, pentagon, hexagon, circle, and with a simple position inclined to both the planes, and planes in the different position, changing the position method. Okay, no problems on so punched plates or composite plates. We are not using any composite plates or punched plates. Only the problems is based on the simple planes. Okay. And module 3, yes, module 3 is a compulsory. You have to attend the module 3. So it is having some more extra importance compared to the module 2 and module 4 or 5. Okay. So module 3 is compulsory. So is a projection of solids. So here definition: the projection of a right regular tetrahedron, a right regular tetrahedrons, hexahedrons, prisms. Okay, we are going to consider for the right side. That's where right regular tetrahedrons, hexahedrons, cube, prisms, cone with an axis inclination, planes resting on HP only. We are discussing only the solids on resting HP only. Okay, so there is no freely suspended problems, or there is no octahedron problems. So module 3 is compulsory. And module 4 and module 5, there is option. Either you can attend the module 4 or module 5. So if you are easy to deal with the module 4, then don't worry about the module 5. If you are more comfortable with the module 5, then don't worry about the module 4. So we are going with, in our college, we are discussing module 5. Okay. Module 4 is optional. Only we are concentrating on module 4. So module 4 is, it is a development lateral surfaces. Okay. Same thing whatever the solids we discussed, so that is a development of lateral surfaces solids, but we are discussing on only a isometric projection, that is module 5. ಸೊ ನಿಮಗೆ ಅಲ್ಲಿ ಆಪ್ಷನ್ ಇರುತ್ತೆ, ಐದರ್ ಯು ಹ್ಯಾವ್ ಟು ಅಟೆಂಡ್ ದ ಮಾಡ್ಯೂಲ್ 4 ಆರ್ ಮಾಡ್ಯೂಲ್ 5. ಸೊ ನಾವೇನು ಮಾಡ್ತೀವಿ, ಆಲ್ವೇಸ್ ಮಾಡ್ಯೂಲ್ 5ಗೆ ಇಂಪಾರ್ಟೆನ್ಸ್ ಕೊಡ್ತೀವಿ. ಆರ್ ಗಿವಿಂಗ್ ಮೋರ್ ಇಂಪಾರ್ಟೆನ್ಸ್ ಟು ದ ಮಾಡ್ಯೂಲ್ 5. So isometric projection. So here solids, so only solids means projection of solids. If the combination of solids, so one placing one solid on another solid, so it's a combination of solids. So here in isometric we are going to uh, so we are going to discuss different types of solids are placing on a different positions, different orientations, one over another. Okay, so in a single view, we can able to see the front view, side view, as well as top view. So that is what the isometric, and it is with some inclination. It is not in the either it is a vertical or horizontal. It is having some inclination that we will discuss in the module 5. So these are the 5 modules. Okay. After completion of 5 modules, there is an course outcomes, COs. That is what the students can deliver. So these are the main course outcomes: CO1, CO2, CO3, CO4, CO5. Okay, first CO1 is prepare engineering drawing as per the BIS convention mentioned in the relevant codes. Okay, so it's a BIS it's a standard one. Okay, it's a standard, it's a drawing standards. So student can able to draw the drawing according to this BIS standard. That is the first outcome. After studying all the 5 modules, the students can able to, okay, if I give any drawing, the students can able to draw a drawing according to the BIS convention. That is the first CO. Second CO, produce computer generated drawing using CAD software. Yes, this whatever the draw it in the manual drawing, and the student can capable to draw the same drawing in the CAD software. Okay, can able to represent same drawing in the CAD by using computer aided drawing softwares. Means they know what is meant by drawing, computer aided drawings. There are different softwares. Okay. And next CO is Use of knowledge of orthographic projection. Yes, we are only deal with the orthographic projections. Okay. And engineering informations, concepts, and represents the same in the drawing. Yes, students can uh, able to understand easily understand the what is meant by orthographic projection, and he should understand what is meant by orthographic projection, and what are its importance and what are the views in the orthographic projections. If I give one drawing, he can able to draw those drawing in an orthographic projection like top view, front view, and side view. Okay, so that ability, once you go through all these 5 modules and develop isometric engineering simple object reading orthographic projections of those objects. Okay, if I give any top view, front view, and side view, the student can able to read those orthographic projection, and he can able to draw it in the isometric view. Okay, isometric view in the orthographic projection or orthographic to isometric. So you can able to either go with, if I give isometric, you can able to draw it in the orthographic. If I give orthographic projection, you can able to draw it in the isometric projection. That ability will comes once you go through all these 5 modules and convert pictorial and isometric view in the simple object or orthographic same. The students can easily, if I give any component, okay, physical component, the students can easily able to draw it those physical component into a pictorial drawing, okay, by either using a CAD or using a manual drawing. Okay, so these are the abilities will comes once you go through all these 5 models. That is what the course outcome. Okay, and come to the scheme of evaluation. So what is the scheme of evaluation for the examination? So which modules you will have, how much marks, and what is the importance? I told first module is only for the understanding purpose, it is not in the examination. Only second module. So second module you have the choice either between the lines and planes, that will covers 25 marks. Yes, in the slide you can see the module 2, there is a choice either line or plane. So in that 25 marks only you will get a 25 marks for planes. If you attend the plane, okay, don't worry about the line. If you attend the line, don't worry about the plane. Okay, only 25 marks. And module 3 is, I told it is a compulsory, it is for 45 marks. It is for 45 marks. And module 4 and module 5, there is an option in the module 4 and module 5, and it is of 30 marks. Okay, so total 100 marks you are going to attend exam for total 100 marks. Okay, and later in the university it will reduce to 60 marks because you have 40 marks as a internal. And come to the solution and sketchbook. So out of 60 marks and 40 marks, 40 is for the total whatever you are going to draw attend for the 100 marks in the examination. In that again there is a division. Okay, so means first you have to write the same drawing in the manually, either in the sketchbook or whatever the sheets we given. Okay, you have to write it manually, so that have 60 percentage of weightage in the 100 marks. And the same drawing you are going to draw it in the CAD software. Okay, either Solid Edge, Unigraphics Pro E, whatever the softwares given by the college, you have to draw it. So it is a 40 of weightage, total 100 marks. Okay, so if you go with the first, there is a projection of lines. Okay, if you take projection of lines in the 25 marks, 15 marks is for manual drawing. First you have to manually solve the problem, it is a 15 marks, and 10 marks is now next for computer representation. You have to draw it in the system and you have to take the printout. So that is 25 marks, 15 plus 25. Same for the solids. I told solids 45 marks, but in the solids again divided, 25 marks is for manual drawing. So manually you have to draw it in the sketchbook or whatever the sheets we given. Okay, it is of 25 marks, and the same drawing you have to represent in the system with the help of software. It is of 20 marks, total 45 marks. And the last one is isometric. Same thing, isometric. First we have to give the problem, you have to write it in the sketchbook or whatever the sheets we given. So it is of 20 marks. And computer, the same drawing you have to represent in the computer, it is carries 10 marks. So total 30 marks. If you add all those things, so total 100 marks, and 40 for the manual drawing, you have to draw it in the manually by using a scale, pencil, and drawing sheet, it is of 60 marks. And the next 40 marks, the same thing you have to represent in the software, it is carries 40 marks. Okay, so if you want to pass pass this exam, this subject, you have to give more importance to the manual drawing because it carries 60 percentage. Whatever the marks, it is of 60 percentage go to the manual drawing. And come to the textbooks and references. Uh, the textbook, uh, generally, ND Bhatt is a one good textbook. RKR Gopal Krishna is also another textbook. And computer aided engineering drawing, okay, by MH Anaya and DC Chandrappa. Okay, so these are the another textbooks. So these are the three university preferred textbooks. Of course, there are so many books are available for this engineering drawing, but these are the three important textbooks suggested by university. And same thing, if you want, you can refer some of the books as a reference book. That is Computer Aided Engineering Drawing by Trayambaka Murthy. It's a one beautiful book, Trayambaka Murthy. And Engineering Graphics by another one book is there. Okay, uh, Prashant Shastri. Okay, and Oxford University. And Fundamentals of Engineering Drawing by Introduction, Interactive Computer Engineering, and by. So these are the references. These are the reference books. And one more important in the reference book is the last one is a primer on computer aided engineering drawing. Yes, it's a book which is given by university. It's a prime. It's a solution book. So whatever the problems you are going to get in the examination, those problems are from the prime book. So primer book, or it is also called as a solution book. In those solution book, computer aided, the projection of planes have a 50 questions, projection of lines have a 50 questions, projection of a solids have a 50 questions, development have a 50 questions, and isometric have a 50 questions. So each will have a 50 questions. So in the examination, you are going to get a question from those 50 questions only. You won't get out of that. Okay, you will get only the questions from those 50 questions only. So it is preferred by university. So it is a solution book or it's a primer book. Okay, so it is considered as a reference book, and better you can take this book for your reference. And of course, I am going to solve all the problems on the same reference book only. Okay.